All right, everyone, welcome back. So we now have Tracy, who's going to be giving a talk on ship it deployment with pip. So let's give a warm welcome to Dan.
Hi, everyone. Welcome to the talk. It's called Ship It, Easy Deployments with Pip, Fabric, and Jenkins. My name is Tracy. You can find me on GitHub, Twitter, the whole gamut. Usually go by DJT5019. It's a bunch of random numbers in my initials. It's cool. I work at a company called AWeber Communications. We're an email marketing company based out of Chalfont in Pennsylvania. You can actually see our company logo around the lanyards you're all wearing. There I do a lot of DevOps stuff, DevOps, the buzzword. I like deployment stuff, I like messing with Chef, and when I began working at AWeber, I realized that we had a lot of ways to deploy our code. That is, take the code we have in our source tree and just push it out in front of customers. Some of them were good, some of them weren't. But I'll get into that a little more later. So, what's this talk about? I'll be upfront and honest with all of you. I have a lot of opinions about deployments, and I am pretty vocal about telling them to people. One of the things I believe in is that, slides are over there, deploying should be as easy as pushing a button. It should be turnkey, your code goes live, and you just watch the money rain from the heavens. Conversely, reverting should also be as easy as pushing a button. Sometimes deployments go south. It's not the end of the world. We all make mistakes. Being able to revert those mistakes quickly and easily makes for a really nice process. When you push code out and you are unable to revert those changes, you're just entering a world of pain, and it's absolutely awful. So pretty much bad pushes shouldn't be the end of the world. I believe that bad deployment processes actually impede development speed and innovation. Bad deployment processes, I believe, kind of create a negative feedback loop. That is, people are unable to push code out easily, so the pushes become larger and larger. The larger and larger a push becomes, the more risk is associated with pushing out your code, which increases anxiety. The more anxiety that you have feeds back into the negative feedback loop, so you push less frequently. It's a self-perpetuating bad loop, and the only way to actually break out of it is to come up with a good development, or good deployment process. On the other hand, a good deployment process allows for easy deploys. Easy deploys means you can deploy faster and more often, which reduces the size of this code that you're deploying, lowers the risk, and it also self-perpetuates, but in an actual positive way. On the same note, easy rollbacks also tie into this positive feedback loop as well. Like I mentioned earlier, everybody makes mistakes. But if you're able to roll those mistakes back easily, they no longer become show-stopping. So people are actually more willing to make those mistakes, knowing that should their code push go south, it's not exactly the end of the world. Life will go on. With trial comes error, and with error comes growth. I believe that code isn't actually useful until it's being used. You can have the greatest functionality sitting in your source code tree, and until it's actually sitting in front of somebody being used, you're not getting a return on your investment, be it time, money, what have you. Unused or undeployed code can be conceptually nice, but practically useless. So let's consider a hypothetical situation. Let's say you have a new feature that's ready for production, or you have a bug fix that was needed in production 10 minutes ago. Something's breaking, and all that is left to do is deploy the code that you have, so you just want to ship it. I mean, what's the worst that could happen? And if anyone knows the context of that squirrel, I've seen it everywhere, but I actually don't know what it's for. So you go to push out your code, thinking, this is going to be great, going to fix the problem, look like a hero, and next thing you know, your ship capsizes. You look like a fool. You could potentially be running different versions of your product in production. Different versions of the code means one version of the code could be working, the other could not. Customers could be having a very bad experience. You don't have a good rollback plan, you're kind of stuck panicking until you try to figure something out, which could be minutes, hours, maybe in worst case a day or so. Or if you push out code, did you just cause an outage? maybe you don't have good enough introspection into your code base or your deployment process to know if the deployment actually succeeded. And that's an absolute nightmare. So ask yourself, do you have more than one way to deploy code across your teams and your organization? If so, that's not so bad. I mean, that kind of gives teams a certain degree of autonomy, but if they have more than one way to deploy code amongst the team, that's kind of a red flag. Perhaps there's legacy deployment stuff there that they never updated or kind of convalesced into the current deployment pipeline, or maybe somebody thought they were clever. Who knows? Having multiple deployments amongst a single team requires additional knowledge and processes for the people coming onto the team, which makes moving from team to team a bit more difficult. Having a single process company-wide, universal. Everybody understands it. It can be very well documented, and it's easy to grab that knowledge. If you have more than one way to deploy a single application, it's just flat out bad. I've actually seen that happen once. We had a Debian package for the main source code and pip packages for all the corresponding libraries, and they were all over the file system. Trying to push out a change for that was agonizing. So to go into a little more about our old deployment setup, I touched on a bit of this before. We did use Debian packaging. It worked out fine for a little while, but unfortunately, the process itself was never maintained. So the tools became crufty, a lot of them were abandoned, and because of that, people started wanting or desiring a new way to deploy their code. One of the ways that they came up with was, I assumed that the thought was, we're going to make this really easy. What we're going to do is just take a snapshot of our source tree, tar it up, and throw it over the fence. What could possibly go wrong? So that was a miserable failure, and we had to kill that as soon as possible. That was just bad. But from that, we kind of discovered that we can take those tar balls and just upload them to an internal PyPy repo, version them, be sane about it. So we began to do that, and the thought was, if we have those packages uploaded on our internal repository, we can modify our Chef source code to install them. We can use Chef for our deployments. That worked out for a little while, but what we found is we run Chef every half hour or so we're deploying every half hour or so, whether you want to or not. That was not that great. We had less fine-grained control of when our code went out and what actually went out. The fourth one is the one I'm going to be talking about today. We use push-based pip installations. We took those same Python packages on our repositories, our internal PyPy repo, and have some fabric glue and stuff. Just push code out to certain targets. It wasn't so bad, but we were missing a lot of machinery required. But the point I'm trying to make here is we had 4 different ways to deploy source code. They were all slightly different, so it was more like 8 or 9. What we need to do is just choose a single way to deploy our code and iterate on it. Just keep one standard way to deploy your code, and things will be a lot less painful. Spend time sunsetting other ways to deploy. The one that we chose was the Python package-based installation. It required the least amount of overhead, and we decided to use it everywhere. Like I said, we were missing some of the machinery, but we iterated on it, developed some of the tooling around it, and it actually made for a pretty nice process. Some of the pieces that we required were Python, obviously, and setup tools to build and publish packages to our internal PyPy. When we version our packages, we try to comply with PEP 440, the standard Python versioning scheme. I believe it was ratified last year or the year before. I can't recall off the top of my head. But one of my coworkers, Dave Shawley, made a tool called setup.ext git version, which actually manages those versions off of git tags, which is really nice. We have internal GitHub, and we use that for our SCM management. Pip itself is used to install the Python packages, believe it or not. Jenkins is used for continuous integration and actually building those packages. Chef is used for initial deployment and service discovery. So we find out which nodes get which package based on Chef searches. And Fabric was pretty much the magic sauce gluing this all together. So let's get into how this works. Excuse me. Just as a kind of overhead of our structure, we do use GitHub internally for our individual project repositories. On Jenkins, we have project-specific jobs. That is a job for project X, which builds tests, runs runs Flake 8, PEP 8, builds docs, and pushes code out to our PyPy. So the process looks like this. Devs commit to master. That is, they make changes to the source tree, and they want to make a deploy, or whatever they want to do. When they merge to master, GitHub notifies Jenkins through a webhook, which kicks off a build of the project-specific job. The project-specific job builds the package, uploads it to an internal PyPy server. We have one, and I forget what it's called, but it works out pretty neat. We mirror packages that we need there, just in case, python.org goes down or something happens. We have copies of our code internally. So after the package is built and pushed out, we notify a generic deployment job. You can tell it's generic because he's wearing some sweet shades. The project uses the Jenkins parameterized job trigger, which is a plugin provided by Jenkins, which you can notify another job to build based on the actions that your job has taken. You can provide any number of parameters to said job. The parameters that we provide are the environment, the chef role, the name of the package, and an optional version for pinning. I'll go back and mention that later when I talk about rollbacks. The generic deployment job, first it queries chef server. This is where Fabric kind of enters the scene. The following actions in the next slides are all within the context of Fabric. Given the chef role provided to the generic deployment job, we query chef using the role name and the environment. For each node returned in the chef search, we do the following. We SSH into each node and upgrade the Python package. It's a simple pip install -u, and the package name, everybody's happy, nice and easy. After the package is installed, we restart the API to load the new code. After the API has been restarted or the workers have been bounced, we test out the new code. Like for the API, we curl the heartbeat endpoint, make sure it returns 200 OK, and it should be operational for the duration of, until we deploy next. After the code's been bounced and the tests succeed, control flow actually returns back to the project-specific job. This is done for a very specific reason. Take, for example, the test of the new API fails in the last job. If we didn't return control flow back to the original deployment job, we could not fail that job, which wouldn't raise enough alerts. This kind of channels the Zen of Python here. Errors should never silently pass unless explicitly silenced. We want to know when our deployments fail. That way we can actually figure out what went wrong. After control flow returns back to the project-specific job, we just do a bunch of push notifications so people actually know what happened. Deploy went live and everybody should know about it. We notify HipChat, New Relic, send build events off to Graphite, maybe email people if the build broke, the blame email, everybody loves that one. After that, it's pretty much rinse and repeat, do that for the rest of your nodes, and that's all there is to that. That process is fairly simple. The key takeaways from this deployment process are, one, you can choose one deployment strategy and iterate on it. At least choose one per team. The code deployed using this mechanism can be deployed in parallel. That is, you can use Fabric's parallel decorator to push out code everywhere all at once, which isn't necessarily a bad thing. However, if you're bouncing the services, they should always be done sequentially, otherwise you just deployed an outage and nobody really wants that. Centralized deployment jobs make for easy rollbacks. I mentioned this a bit earlier. The parameterized build plugin in Jenkins, we set it up so that it accepts a version. You can build the generic deployment job, provide all the information you want, and if you specify a version, that version will be installed to the corresponding environment that you provide. So if something goes wrong, the latest build fails, you just click on the Jenkins job, provide your version, push the button, and production is saved. It's pretty neat. And one of the coolest things about this is other code bases can actually use this similar deployment setup. The only things tying this to Python are pip and our internal PyPy server. We noticed this after rolling a bunch of updates to some of our internal Node.js services. We built them in such a way that they can use NPM and an internal NPM server for managing the source code and the deployment processes. This actually worked out very nicely. However, with all good things, it's not all Skittles and beer. There are some problems here. First and foremost, fixing and updating the old code deployment processes is very painful. It's always like that. People like to tack on the name legacy stuff to that when they don't want to touch it. I mean, there's nothing you can do but kind of slog through it. This cannot be a one-person thing to go back and update these. This requires teamwork, it requires coordination, and everybody needs to buy into this process. If you don't have that buy-in, you'll never actually get this thing out and about. One of the things that we dislike about this process is that we are strongly coupled with Chef for our service discovery. We use Chef for our node provisioning, and it does do the initial deployment of our packages. That is, when you bring up a new VM, it'll do a pip install of your packages, grab the latest production one, and then it's out of the equation. However, we also use it for service discovery, which it can work pretty well in some cases, but we've been less than impressed with some of the edge cases. Mostly Solar issues. It's not that big of a deal. Jenkins itself is not the greatest continuous deployment server. It's great for continuous integration. It runs tests very well. You can trigger other jobs. It's all very nice. But actually having it manage our deployments has gotten kind of painful. And the triggered parameterized build job plugin that I mentioned is not without its flaws. You cannot pass environment variables properly, and it introduces a new bash context. It's got a lot of weird edge cases that you kind of have to work around. At that point, your continuous deployment server is kind of fighting against you, and if that happens, you're kind of fighting a losing battle. And with most new projects, our initial version of the deployment was pretty gnarly. We used Fabric in a pretty weird way. What we did is we have a separate repository with our Fabric file and version that separately, maintenance requirements, and all the things that that Fabric file needs to operate. However, Fabric itself doesn't really like the idea of having, how do I say this? We packaged up the Fabric file into its own little sdist, upload it to our internal PyPy, and pull it down as a requirement. However, the version of Fabric that we were using didn't really like you pip installing Fabric files. We worked around that by just maintaining a separate GitHub repository with all the build code that we need, including the Fabric files, and it's a simple git clone in the job at that point. It worked out pretty nicely. So those are some shortcomings. You know, it's not all doom and gloom, but we do want to move on from here. Some of the next steps that we want to take are, we want to hop aboard the Docker hype train. Everybody seems to be doing it. It seems like it's really neat, and will solve all the problems we've ever had and didn't even know we had. We want to look at tools like Rundeck instead of Jenkins as a continuous delivery server. If anybody out there has actually used this, I'd like to talk to you. We've kind of been knocking it around, but haven't really settled on it due to kind of a lack of situational awareness around it. But from what I've read, it's pretty much just like a service that sits out here and runs arbitrary bash, kind of like Jenkins, but it's not very repository-centric. Some of the things that we want to introduce additionally are trend-based monitoring, like Skyline, which I believe is used by, I can't remember the name of the company off the top of my head, or Riemann. The reason we want to introduce things like this are because point-in-time metrics, kind of like Graphite, are useful, but they don't expose trends easily. That is, if you push out a change you push out a deployment, and something begins to deviate, it's kind of difficult to pinpoint that with a very narrow scope of your metrics. With something like trend-based monitoring, you can have historical data to compare against and raise alerts when things seem anomalous, which is very useful. Instead of using Chef as a service discovery mechanism, we want to use something, well, we were looking at something like Console, etcd, or the veritable Zookeeper, which are more well-suited to the task at hand. Additionally, the deployment process that I kind of described here is very simplistic. There's not a lot of moving parts, which is kind of one of its benefits, but it doesn't really facilitate complex deployments that others may need. I mean, deployment itself is not a one-size-fits-all type of thing. We kind of want to look at more sophisticated deployments, including partial rollouts. For example, if you use Amazon, maybe deploy to one availability zone and see how that does before spraying the code everywhere and hoping to God that it works. Additionally, we want to look at kind of designating one set of nodes or VMs as canaries. Push the code out there, make sure it doesn't break. You have your monitoring in place, Nagios is happy, then you push the code live. The reason being is if the canaries die, the rest of the code is still functional. That means only a very small subset of your customers are impacted by this outage and not everybody under the sun, which is a bad time. So, kind of to wrap this up, good deployments can help innovation, bad deployments can hurt it. That's that positive and negative feedback loop I discussed earlier. Deployment pipelines are never done and they're never truly finished. They simply exist as states in time. They require constant maintenance and love. Furthermore, they require more than one person maintaining them. The more people you have involved with this, the better. You have a wider spectrum and view of the problem at hand and how to solve it when not limited to your own viewpoint. Deploy quickly, deploy often, reduce the size and scope of your deploys, and iterate on what works. That's all I have. Thank you.
All right, so thanks, Dan. We're going to have one-on-one questions, so if you have any questions, come here, and we're going to be moving on to an open space after. So once again, thank you, Dan.
Thank you very much.